Another energy hog that is in this range of greater than 1 million tons of carbon footprint are the data centers. They're at 130 million tons of CO2 equivalent. They were at 130 million tons CO2 equivalent in 2010, and I'm recording this basically at the end of 2021. You can imagine that things have gotten much worse. The forecast here, or the projection made during that time, was 250 to 340 million tons of CO2 equivalent for 2020. The footprint of the world's data centers is currently the same as 1/7 of the UK's footprint, or 1/4% of the global total, and this is going back to 2010. Remember, we talked about paper versus digital media, messaging, cell phone calls, etc. At some point we convinced ourselves that storage is cheap, so we can store everything, and we want to store our old messages, emails, photos, documents, digitize every book on the planet, and so on and so forth. So slowly it has morphed also into a field of study or analytics called big data, which is now used for all sorts of things, including data being collected on you every time. Even when your phone is just sitting there, it's listening to you, your TV is listening to you, and it's collecting data, and it's feeding you personalized information. For example, when I open New York Times, it knows that I'm coming from India, so it puts personalized ads for me from Indian outlets. Okay, so imagine, and New York Times is the most conscientious about climate change, and its profit model is still about selling stuff. Okay, so how much data gets gathered or collected or produced? 3 important statistics about how much data is created. I took these from Finances Online. Every minute, 41,666,667 messages by WhatsApp users. This keeps going up. Video calls, more than 1 million, almost 1.5 million hours of video streamed by Netflix users, stories posted by Instagram users, messages by Facebook users, photos shared by Facebook users, and so on. So estimated data consumption from 2021 to 2024, as was projected in 2020, went from 74 zettabytes, that is 10 to the 21, expected to climb to 149 zettabytes, so more than double. Data growth in 2021 at 2 trillion, so it's volume of data created every day, emails sent every second, 67% of which are spam. 82% is the share of video in total global internet traffic at the end of 2021, expected. 230,000 new malware versions created every day. Actually, this is actual data by now. 278,108 petabytes global IP data per month by the end of 2021. Here is another way to look at it. I'm not going to read, but you can see how many categories there are and what the numbers are. The number of people, the amount of data, number of people. So 463 exabytes. We don't even blink at these sorts of numbers, because the challenge that is perceived by humans is how to manage such large data, how to comb through such large data, how to extract personalized or other patterns of information out of this data, and how to use it for all sorts of applications, good and bad. So there is this constant battle of what is whether privacy is maintained or not, and so on and so forth. But at this point, there is basically nothing you can do. Data is being collected on you all the time. Okay, media usage in 1 minute on the internet as of August 2020. WhatsApp messages we already looked at. Voice or video calls, amount spent by consumers online, which directly corresponds to carbon footprints. Reddit hours streamed by Netflix, stories. So the same things we looked at, but additional payments sent by Venmo. participants hosted in Zoom meetings. COVID made a revolution out of these online meetings, Facebook messages and Facebook photos. Data volume expected between 22 and 2024 measured in zettabytes, 10 to the 21 bytes. 2022 at 94 and 2024 at 149, as we saw before. What is the future of data then? This is where the energy consumption comes in, because we are worried about carbon footprint. And all this data that is stored, it is stored in these wall-to-wall disks and storage systems and computers that are doing input, output, grabbing data, putting in data, searching through data. This is one of Zuckerberg's data centers in Europe, I think in Switzerland. And there is the energy forecast. 9,000 terawatt hours is what would be needed by 2030. Widely cited forecasts suggest that the total electricity demand by information and communication technology will accelerate in the 2020s, and that data centers will take a larger slice. So networks, production of ICT, consumer devices like televisions, computers, and mobile phones, and data centers. So you can see the data centers here accelerating on top of these networks, wireless and wired. So 20.9% of the projected electricity demand is going basically in this overall ICT band, information and communication technology, including storage. The chart above is an expected case projection from Anderson Andre, a specialist in sustainable ICT. In his best case scenario, ICT grows to only 8% of the total electricity demand by 2030 rather than 21% as shown here. That's the best case scenario one would expect according to him. Global electricity demand in 2015. Here is where we were for these few things: networks, production of ICTs, consumers, and device centers. So the other demand is here. So you can see a small chunk. Best case by 2030 is here, and expected is at 21% here. Internet explosion. Internet traffic is growing exponentially and reached more than a zettabyte in 2017 already, and 40,000 terawatt hours were consumed by this 1.1 zettabyte in 2017. Okay, so no good news there, even though you want to keep all your memories forever and look them up whenever you feel like, in the middle of the night or during the day or during the office hour, maybe even while driving. Energy scale. Global electricity demand is at 20,000 terawatt hours. Energy used by ICT is 2,000 terawatts by 2030, I think. Data center electricity demand is expected at 200 terawatt hours. Bitcoin, another thing that is taking off now in terms of wanting to make money. Most people don't even know what Bitcoin is or exactly how it works, but a lot of crunching goes on every time somebody is trading in Bitcoin. So that Bitcoin trading basically initiates a computing race, and that by mid 2018 it was consuming 20 terawatt hours, and this is expected to keep growing as well. Green growth. The ICT industry dominates corporate agreements to purchase renewable electricity. So it's not about reducing ICT consumption of power, but it is about making sure we get more renewable electricity. Is that a good thing? Not necessarily, because it just competes with the others, which is here. So this is the total in 2010. ICT took up so much. In 2016, ICT was a much bigger percentage of the total green growth consumption. So mostly it's disappearing in these sorts of things. Suggested things include things like efficient hyperscale data centers that are predicted to swallow up half of data center electricity demand by 2020. We're already in 2021, so one can look up to see what has happened. As smaller and less efficient centers shut down, these hyperscale centers will take over, just like Amazon is taking over lots of traders and small mom and pop stores and booksellers and so on. Traditional data centers in 2020, cloud data centers, non-hyperscale, and hyperscale data centers. In 2020, this was projected before 2020. So here we are with the traditional, cloud, and hyperscale, adding up to about 200 terawatt hours. So this gives you a sense of just how energy hungry everything we do becomes in the end. It's great that we can save all our data and photos and messages and look things up whenever we want. It can help legal cases, courts, businesses, criminal cases, transactions, and so on. But everything comes at a cost. Everything we do has unintended consequences in terms of energy demand and carbon footprint, which is our main concern here, carbon footprint. But we cannot just look at carbon footprint without seeing where it's all coming from and where it's going, even when you focus on one particular thing like a data center, which is in the range of greater than 1 million tons CO2 equivalent carbon footprint. Okay.